Now, some of you guys made some predictions on which simple machine you thought would make the work the easiest. Now, I'm not going to go into the why part because I just want to hear some predictions to see any differences or if a lot of people got the same thing. Quanasia, what did you predict? Pulley. Okay. Daishwan?
Inclined plane.
Inclined plane was going to be easiest. Okay. Okay, good. So again, here we've got 8 with the pulley, 1 person with the inclined plane, and then 5 people with wheel and axle. So it's kind of between these two. So as you guys are going around, keep that prediction in your mind. All right, boys and girls, listen carefully. Do not start yet. When you hear the bell, that's when the time will start. I'm going to time you at each station. Those of you at the data analysis, what you can do right now is just read, okay, to see the different questions for each station while you wait. So what's going to happen is the data analysis, you're going to go to the pulley station. Pulley, data analysis. Lever, after that, data analysis. Inclined plane, girls, pay attention to data analysis. So you're going to go to the seats to write your summary question. From there, wheel and cart, okay? And again, back to the desk for data analysis. So in a big circle, clockwise, okay? Jada, are you guys waiting? Again, when you hear the bell, that's when it starts. When you hear the bell again, stop, look, and listen, and I'll tell you when to rotate or when to go back to your seats. Do you have any questions before you begin?
No, ma'am.
Okay. 1 second, let me get my bell. You may begin. With lesson 3, something that I was able to do is put all the simple machines on the outside of the classroom, hanging the pulleys on cabinet doors versus your classroom door, and putting the data analysis stations were at the desks where the children normally work. So each group of desks was near one of the simple machines. So once they were done testing the simple machine, putting in their data of how many forces or newtons were needed, and they went together at just a station nearby of desks to come up with their summary questions so they could sit at the tables and work. So it kind of balanced out in a weaving pattern but still working clockwise where it wasn't too confusing for them.
Let's move this over a little bit.
Eight and a half.
Okay, that was B.
Oh, 6. Yeah, 6.
He's asking about the rope, right? So less. So the more rope I have, the less
harder.
less newtons
that I need to lift.
I'm gonna.
So that's the relationship.
Want to try it again? Try that one again.
By 5 and 2, 2, 2.5, what you guys got. And then looking now at the length of rope, so it says, what is the trade-off? The trade-off is
A little more, right?
So look first at position A. Do you have a long lever arm or a short lever arm? There you go. Because here's my load, and here's the fulcrum. So this is long, isn't it? Okay, then I go about halfway, and then I have a short. So, yeah, it's kind of in the middle. So, again, what's the relationship between the length and my force? The length and my force, the length and my force. The harder to lift. You want it to go all the way up that board. All the way up, as far as it can. Yeah, girl. Good. Now, did you do your reading as you did it? Okay, good. Keep going. Okay. Okay, good. By hand. So now you're going to pull at the length of this inclined plane. There you go. Read your newtons as you do it. Good job. 2. Good job. Keep going.
What's the relationship between the length and halfway and the mountain?
So what's the relationship between? Very good. So what do you think would be better to have for an inclined plane? A longer one or a shorter one? Very good.
Can't you put a conveyor?
Well, and that would make it even easier, right, for a lot of that work. But you're right, the longer the better. Similar to like what we thought with the double pulley, huh? Yes, and pull by hand first. And this is your start, and you go to 6 inches. So you might have to move out of the way, Jada, over here to the side on the carpet. And your last page is your wheel and cart. So try it by hand first. Pull it. This is the start, right? Oops. Attach it again. And then this is your no wheels and wheels, right? Okay, and try pulling it. You might have to stand up, and you might have to move so she can move it with her hand so she can see. Read your newtons as you go. Keep going. You want the water to be all the way past 6 inches. So keep going.
Really no Newton. Now let's try without wheels. Okay, and you do that.
Keep going, keep going.
1.5.
No, 2.
How we doing, guys? Okay. Now, what direction did you pull? Yeah. So do you have that to show there? So you had to bend over, but then you had to pull what? Forward or across, right? So you had to pull forward or across. So that's what you want to actually write in there. I would write that in. Because you don't have that option to circle, do you? So circling the bend over and the pull forward, right? And write in pull forward. Good. Okay. Last one. Okay, so then put that down, and if she gets 4.5, put that down by hand, and then try the pulleys. So you can each do your, switch your pulleys after you do it 3 times each. Okay? Very good. What don't you get, Gina?
It's the same thing.
Okay, look carefully. Okay? What do you notice about this pulley, Gina? Look at this pulley. What do you notice?
These have 2 things.
Right. These are the actual pulley part. This is called a double pulley, just like you said. It has 2 of those parts. And look at the rope. What's the difference between the rope for here when I pull, right, versus over there when I pull? Is there more rope or less rope? First thing they want you to do is compare how many newtons of force were needed to lift the load using the single and the double. Well, how many forces were needed for the single pulley? How many newtons? 5. And how many for the double? So what's the difference? 3 newtons, right? 5 minus 2. So there's a difference of 3 newtons between the single. So which one was harder? The single pulley, okay. Okay, the single pulley had less rope, which made it then become harder. So then what's the trade-off? The more rope I have, there you go, that's your trade-off. So even though I need more materials, more rope, it becomes easier to lift. Lesson 3, I love the whole hands-on aspect of it, where the kids get to, in a way, play with it, but also are looking for certain aspects that we have talked about with the simple machines. So I like that they have to actually work together and talk about the different forces used and come up with the ergonomics of how are they moving the particular parts and the motion of it. So I like all of the hands-on, and it gives them that opportunity to really test each simple machine and see exactly how it works.